Welcome! Today, we're jumping past the basics of Python's lists and tuples. We're going to get into the good stuff, how to write elegant, single-line list comprehensions, really understand the power of immutability, and ultimately, write some seriously clean and efficient Python code.
So here's our game plan. We'll kick things off by mastering how to slice and dice lists to get the exact data you need. Then, we'll look at some powerful methods for changing lists on the fly and the really Pythonic way to create them. And we'll wrap up with the big strategic question. When do you use a flexible list versus a lockdown tuple?
Okay, let's dive right in. First up, slicing and indexing. Honestly, getting good at these is absolutely fundamental if you want to work with list data effectively in Python.
Think of it like this. Slicing is your go-to tool for grabbing whole sections of a list. Now, the key thing to remember here is that slicing doesn't mess with your original list. It always hands you a brand new one. Indexing, on the other hand, is more like a laser pointer. It just pinpoints one single item.
So here's the code we'll be playing with. It's just a simple list of numbers 0 through 9. Now look closely at lines 2, 3, and 4. We're using that start and step format. And by leaving parts of it blank, we can do some pretty cool things, like grab a subsection or skip elements, or even reverse the entire list. Let's see what happens when we actually run this.
And here we go. This shows the power of slicing perfectly. The first example, mylist25. It grabs the element starting at index 2, all the way up to but, and this is important, not including index 5. The second one, 002, leaves the start and end blank but uses a step of 2, which gives us every other element. And that last one, 00 minus 1, well, that's just a classic Python trick for completely reversing a list. Super handy.
Okay, so we know how to access data. But what about actually changing the list itself? Well, Python gives us several built-in functions or methods that let us modify lists in place, which just means we're altering the original list directly. For this demo, we're going to start with a super simple list that just has 1, 2, and 3 in it. Then, we're going to run a sequence of operations on this one list to see exactly how each method affects it. We'll append, then extend, then insert, and finally, we'll pop an element out.
Now, the really crucial thing here is to get what each method does. So, .append adds one single item to the end. Simple. .extend is different. It takes something you can loop over, like another list, and adds each of its elements. .insert is all about precision. You give it an index and an element, and it sticks it right in that spot. And finally, .pop does two things. It removes the element at a specific index, and it actually gives it back to you.
Let's trace this through step by step. We start with 1, 2, 3. Calling .append 4 makes it 1, 2, 3, 4. Then .extend 5, 6 turns it into 1, 2, 3, 4, 5, 6. Next, .insert 1, 10 pushes everything over, giving us 1, 10, 2, 3, 4, 5, 6. And finally, .pop 1 removes the element at index 1, which is now 10. That leaves our list as 1, 2, 3, 4, 5, 6, and the pop operation gave us back that value 10, which we caught in our variable.
Okay, now we're getting to one of my absolute favorite features in Python. Seriously, list comprehensions are a hallmark of clean, efficient code, what a lot of people call Pythonic. They basically let you build entire lists in just one single, beautiful, readable line. I like to think of it like this. Instead of writing a whole clunky for loop to build up a list piece by piece, you're writing a concise one-line recipe. It just describes the new list you want based on an old one. It's compact, it's readable, and a lot of the time, it's actually faster. Let's see it in action. Line 1, we've got a simple list of numbers. Then, on line 2, we create a new list called squares. Just look at that syntax, x squared for x in numbers. It reads almost like plain English. I want x squared for every x that's in my numbers list. And just like that, squares now holds the square of every number from our original list. I mean, come on, that is so much cleaner and more direct than writing out a 3 or 4 line for loop to do the exact same thing. But here's where it gets really cool. List comprehensions aren't just for these simple one-off operations. You can actually scale this whole concept up to handle much more complex logic, even replacing nested for loops. So in this example, we have a matrix, right? It's a list of lists, and our goal is to flatten it into one single list. Now, look at that comprehension on line 2. It has 2 for loops. The trick is to just read them from left to right, just like you would with nested loops. For each row in the matrix, and then for each number in that row, give me the number.
And the result is exactly what we wanted, a simple one-dimensional list that has all the numbers from the original matrix. I'm telling you, this is an incredibly common and useful pattern, especially if you get into any kind of data processing or scientific computing.
All right, let's switch gears from lists and talk about their cousins, tuples. We're going to check out a really neat feature called packing and unpacking. It just makes your code so much cleaner and more intuitive when you're working with multiple values at once.
At its core, this is all about bundling and unbundling data in a really convenient way. Packing is when you group a bunch of values together into one tuple, and unpacking is just the reverse. You take a tuple and distribute its values out into separate variables.
Let's look at the code. On line 1, we're packing. And notice this, we don't even need parentheses. Python is smart enough to just automatically create a tuple from a sequence of comma-separated values. Then, on line 2, we unpack. Instead of having to access elements with indexes, like packed tuple 0, we can assign them all in one go.
And there's our result. After just that one line of code, the variable name holds Alice, age holds 30, and city holds New York. It's just a really elegant way to handle groups of related data. This brings us to probably the most important strategic decision you'll make when using these data structures. When should you use a list, and when is a tuple the better choice? Well, the answer almost always boils down to one critical difference. And here it is. It's all about this concept called mutability. Lists can be changed after you create them. You can add, remove, or modify elements. We call this mutable. Tuples, on the other hand, are immutable. Once you create one, it is locked in. Its contents are fixed, permanent, you can't change it. So, here's the rule of thumb. Match the data structure to the job. Use a list for anything that needs to be dynamic and change over time, like the items in a shopping cart. Use a tuple for fixed data that you know should not be altered, like coordinates or an RGB color value. This guarantee of immutability is really powerful. It doesn't just protect your data from accidental changes, it also lets you use tuples in places lists can't go, most importantly, as keys in a dictionary, because Python has to know that key will never, ever change. And really, that's the key takeaway here. It's not just about what these things can do, but about making a conscious choice. So as you're writing code, ask yourself this question. Thinking about when to choose immutability, that's the secret to writing safer, more predictable, and way more efficient Python code.